camera in action, right? So you guys did the warm-up yesterday for 1-2. Some of the key terms that we're going to talk about today, if you'll write these down, we're going to discuss like terms. Hey, y'all probably have heard of like terms before. That lasts all through algebra, working with like terms. We're going to discuss simplifying because there are some instructions today that'll say simplify. When I first started teaching at Ninnekah years ago, I had an elementary kid. We were talking about simplify. Now I said simplifying the fraction, and he would say, "Mr. Bush, do we have to simplify that?" He really thought it was the word simplify. He was just cool. There is no L after the F. And we're going to look at evaluating expressions, what evaluate means. So you might be comfortable with these, you might not be comfortable with them. Either way, we'll practice those types of terms. First thing you see on this page, all this stuff is straight out of the curriculum. All you'll see on these booklets are the important things. This is something you've heard of before, but just to remind you, the order of operations still exists in Algebra 2. You still follow this? Just like you've done. Please excuse my dear Aunt Sally. What happened to Sally that we have to excuse her? Does she have bad gas? Is she always late? Is she rude? Why don't we excuse Aunt Sally? I don't know. Everybody comfortable with this order of operations? Okay, turn the page. Now we look at some key vocabulary right here, things that are important. Variables, that's what makes things algebraic, is when you have a variable. There's a symbol, usually a letter, like the letter X, to represent some unknown. That represents one or more numbers. An expression that contains one or more variables is an algebraic expression. So we'll look at some examples of that. Or variable expression. And when you substitute numbers for variables in an expression and follow the order of operations, you evaluate. So there's that word. When I used to think of evaluate, I think of when a teacher's gone, you have a what? A sub. And that's what we do when we evaluate. We sub out the letter, put a number in its place. So we're going to simplify expressions through evaluating by subbing out the letter and putting a value. Just some properties for simplifying algebraic expressions. Some of this will be real simple. If you were doing a minus b, that could also be known as a plus a negative b. A divided by b could be written as a over b. It could also be written as a times 1 over b. There's a lot of ways of looking at division. There's the distributive property again. A variable or a number on the outside of parentheses can be multiplied to both terms on the inside. Of course, we know that 0 times anything is 0. We know that if you were to take any letter A or anything A can represent a number or a letter. Anything multiplied times -1 does what to it? Turns it negative. If this was negative already and you multiply it times a -1, it'd become positive. So multiplication by -1, you can say right here, I like to add this, it changes the sign. You'll see that a lot. Keep that part simple. If a -1 is being multiplied to something, the sign will be changed. Opposite of a sum, this just shows when there's a negative, there's an imaginary 1 right there that distributes through. So just like here, -1 changes the sign, we would distribute a -1 through, and the A becomes negative, and the B would become negative. Just the opposite here, opposite of a difference. If you distribute a -1 there, then the B is positive, where it was negative, and now the A is negative where it was positive. This is just basic things for simplifying. If you had a negative on the outside of this parentheses, it would be applied to both. Negative a times the b, a times the negative b. That negative sign is in both parts. How many negative signs are here? One. There's one here. There's one here. And then right here you see that double negative makes a positive. All right, so now here are some other things. We're going to practice this. I like this part right here. Focus on this right here. This really explains terms. Or it kind of helps you understand terms. How many terms are in this expression? Two different terms. You have an x squared term and you have a y term. X squareds and y's, and each of those have a coefficient. There are 7x squareds here and there are 3 y's there. So we have things like terms, we have things like the coefficient of those terms. We're going to look at some examples of those. Okay, let's do that. Flip over to where you have some space to write. And we're going to look at some examples. This will be an example of how to simplify. Fly. So I'm going to put something there, I'll do all kinds of examples. So example 1, what if you had nothing but 6x plus x? What would we do there? Is there anything I can do? How many terms are there right now? 2. There's a 6x, its coefficient is 6. There's a x, its coefficient is an understood 1. Are they like terms? Yes, because the variable part of it is the same. So we can add them. You would have 7x. That's combining like terms. What if we had 11t plus 3t minus 5? 3 terms. Are any of the 3 like? Yeah, there's some that are like. It's the 2 t's. So if I was to simplify this, all I could do to simplify it is combine the like terms that are there. What would that give us? 14t minus 5. Very good. And what if we go a little bit crazier? What if we say 16xy minus 4xy? If I was to simplify that expression, Wesley, what do you think it'd be? That's right. xy is the term. It's xy terms. So that's like. They're both xy, so we can simplify by subtracting. Make 12xy's. Let's try this example. 4a minus 5a plus 1. So this expression can be simplified, but I could apply a property here first. What property would I apply to this part? Distribute. Now let's distribute the negative 5. And remember, when you're distributing a negative in, it'll change signs. So the 4a, I'll just leave it there because I really can't do anything to it, that term. This will be minus what? Minus 5a plus or minus? Minus 5. Because 5 times 1 is 5. And it's a negative times a positive. Now, guys, I will be honest. When I start doing this kind of things too fast, sometimes I forget to distribute to both parts in that parentheses. I've been known to write negative 5a plus 1 before. Anybody ever done that? Like, you get in a hurry and you forget, oh, when I distribute, it goes to everything. So by using the distributive property, by paying attention to that negative sign, now we have something that has 1, 2, 3 terms, and I think these two are like. 4 minus 5a is negative 1a, yep. So that's negative 1. I'm not going to write the 1. I'm going to use it as an invisible number. Ones are understood. So negative a minus 5. We have cold students in the room. All right. So this is an example of simplifying. It's understanding there's going to be all kinds of terms in Algebra 2. You'll have lots of different terms. This is a bonus example. What if I have 5xy squared plus 2xy? 5xy squared plus 2xy. How many terms are there? 2. We got our xy squareds. We got our xy. We got a 5 here and a 2 here. What can I do to this expression? Nothing. These are not the same kind of term. This would either have to be just xy or this would have to be xy squared for them to be like. So since that is simplified. There's nothing more I can do there. Okay. Then let's look at some examples of evaluating. Evaluate. Remember, it's like, I like to call this the same thing as substitution. I don't know if I spelled that right. So let's say we have an example here where we go 5y squared plus y plus 1, and we say our y's are equal to 4. So this expression over here has y's in a couple places. We can replace or sub out the y with the 4. Now this is where we have to pay attention to order of operation. So let's start by just putting the 4 in. So I'm going to replace. I'm going to say 5, still there. There's a 4 right here. I use parentheses when I bring it in when there's an exponent around and other things. Plus a 4 plus 1. So both y's became 4. This is where I have to pay attention to. Please excuse my dear Aunt Sally. One of the biggest mistakes is for this to become 20 squared. So that's an easy thing to go like, ooh, 5 times 4, 20. I know that. Then I'll square it, 400. What did I mix up there? What should I have done first? Yeah, because exponents comes before multiplication. This would be to multiply. This would be exponent. So I want to write this as 5 times 16 first. And I can go ahead. I know this isn't saying fall in the correct order here, but I can go ahead and write the 4 plus 1 is 5. Because whatever that is, it'll be added to this product. It's not going to change the overall simplified answer. I don't have to wait on that step. 5 times 16, I believe that's 80. So 80 plus 5 equals 85. All right, let's do a couple more of these. What if, here's the thing I'm going to throw at you. We got a negative sign sitting in front of a t squared minus 3t inside of parentheses plus 2. And we're going to say our t equals 5. So we have this expression. Got some t's in here. Got to put the 5 in. That negative sign is an invisible negative what? 1. It is the same thing as that 5 right there was to that y. So this had a 5 in front of that y squared. This has a negative 1 in front of that t squared. It is important that when I put this 5 in, I do not apply the negative to it first, because that'd be the same thing as the wrong order. I'd be multiplying 5 times the negative 1. I'm going to leave the negative there, and I'm going to bring this 5 in parentheses. Minus 3 times 5 plus 2, all in parentheses. So I just brought it in through substitution. I like to, Stephen, this is where I like to work it out. So when I make a mistake, I can go back and see where I did it at. So what's this first part? What should it equal, 25 or negative 25? This should be negative 25 because I need to square and then apply the negative through multiplication. That's an easy mistake that gets made sometimes. Sometimes we'll go, oh wait, that's negative 5 squared. Negative 5 squared is positive 25. That would be out of order. Do the exponent first, then multiply. Minus, I'm going to keep this as a parentheses for now. That's going to be 15 plus 2 inside there. Not going to do anything yet. It's still negative 25 minus how much? 17. We'll just, now we got this parentheses simplified down. This is how Mr. Bush sees this. Negative 25 minus 17 is the same thing as negative 25 plus a negative 17. That's how I do those. When I have a negative up here and I'm subtracting more, I say, well, that's the same thing as plusing a negative. That's in those properties. We talked the other day, when you add the same sign, you add and keep the sign. So this will be a negative, how much? 35, 42? Yeah. Altogether negative 42. Okay. You will have some practice on these kind of things and a little bit more we can work through. Our goal here is to take your time on these kind of things. Don't get in a hurry. This is just to practice understanding these concepts. We'll see if we have any questions as we go.